Today we are going to start with logarithmic function. This is section 4.3 in your book. So we have to define what's a log function first. Let's read the definition. If x and b are positive real numbers such that b is not equal to 1, and then y is called log of, that's how you pronounce it, y is equal to log of x with base b, is called logarithmic function with base b, where y is equal to log of x with base b. What it means is basically that b, which is the base here, raised to the power y, is equal to x. So basically what log function is, this is inverse of exponential function. We know that an exponential function is a one-to-one function, so we can find the inverse of it. What is the definition of inverse function of an exponential function? That is called log. So what you need to remember is that if we have b raised to power y is equal to x, so we say what should we raise the base b to so as to get x? That answer would be y. So log is defined as that. When we read log of x with base b, what does that mean? What should we raise b to so as we get x? The answer is y. Given log is equal to y is equal to log of x with base b, the value y is called the exponent to which b must be raised to obtain x. The value of y is called the logarithmics, b is called the base, and x is called the argument. The equation y is equal to log of x with base b and b raised for y is equal to x. They are both basically same equation. They both define the same relationship between x and y. B raised to power y is equal to x, or what should b be raised to get x is y. It's one and the same thing. It's just two different forms of the same expression. This form is called logarithmic form, and b raised to power y is equal to x is called exponential form of the equation. So both of the relationship are exactly the same. Let's do this example number 1. It says write this equation in exponential form. A given equation in logarithmic form. It is log of 16 with base 2 is equal to 4. So how do you read it? What should the base 2 be raised to? Is so that answer is 16. That number is 4. So when we have an expression log of base 2, 16 is equal to 4, this and this number, they both are called the base. This and this, they are called exponent, and 16 is argument. Let's look at part B. The question is, for the given logarithmic equation, you have to write an exponential equation. Log of 1 by 100 base 10. So what should 10 be raised to? 10 should be raised to negative 2 to get 1 by 100. Part C, the base is 7. So 7 raised to the power, the exponent 0 is equal to 1. So these are your exponential equations for given logarithmic equations. Example 2 is, on the other hand, write each equation in the logarithmic form. We have some exponential equations. We have to write them into the logarithmic form of the equation. So question number 2 is, we have 2 raised to power 5 is equal to 32. So you need to understand that the base here is 2. So log's base will also be 2. 2 should be raised to 5 to get 32. So we can say log of 32 with base 2 is 5. What should 2 be raised to get 32 is equal to 5. Part B, what should be 10 raised to to get 10,000, that number is 4. So we already know in the exponential form that 10 raised to power 4 is 10,000. When you write it in the logarithmic form, you write log, meaning what should we raise 10 to get 10,000. Log of 10,000 with base 10 is 4. Next, this becomes the base of the log. So log base 1/8. What should 1/8 be raised to get 64 is -2. Next, we have equivalent property, which we sometimes use in this chapter. So if we have b raised to power x is equal to b raised to power y for some number b which is positive, if the exponents of b are same, that means the powers should be same too. If b raised to power x is equal to b raised to power y, then x has to be equal to y. That is the equivalence property of the exponentials. Let's see how we can evaluate log function. We just defined it. So how do I write it? Log of 16 with base 4. We have to find it. Let's assume that number is y. That means 4 should be raised to y to get 16. You need to figure out what is y. What should 4 be raised to get 16? I think that number is 2. 4 square is 16. So that answer would be what? 2. Log of 8 with base 2. So what you need to ask yourself, what should 2 be raised to get 8? What should 2 be raised to get 8? I think that answer would be 3. So this number is 3. Next we have log of 8 with base half. That means what should half be raised to get 8? Because it's half, it has to be reciprocated. So the answer will be -3. So this answer is -3. Then we have some special logs. The first one is called common logarithmic. If log function has the base 10, it is called common logarithmic function. And it is a convention in mathematics to just write it as log of x. So whenever you see a function y is equal to log of x, if the base is not mentioned here, that basically means that base is 10. Base is equal to 10 for common log, okay? And it is always written as just log of x. In logarithmic function, if base is e, remember the e is an exponential number which we talked about in exponential functions section, then it is called a natural logarithmic function. And it is convention to write natural logarithmic function as lnx instead of log of x with base e. So we do not write log of x with base e in the books. It would be always written natural log of x, lnx. Ln means natural logarithmic of x. So in your calculator, I just wanted to show you here it is the log, log, that is called the common log, and its inverse function would be 10 raised to power x, which is the second function. Similarly, natural log is an inverse function of e raised to power x. So here ln is the natural log on your calculator. So if you have to find natural log of something, you will just press natural log and say natural log of 4. That will give you an answer, okay, using the calculator. Now, in general, what we have to find, let's say question number 4, log of 100,000. So no base is mentioned here. That means this is common log, meaning this is log of 100,000. If base is not mentioned, this is basically 10, right? So the question is, what should 10 be raised to get 100,000? That number is what? That number would be, I think, 5, right? So the answer to this number is 5. Next we have log of 0.001. That is also common log because base is not mentioned. You need to see what is this. What should 10 be raised to get 0.001? I think that should be negative number because it's in the reciprocal 1 by 1000. So negative 3. Next, natural log of e raised to power 4. So natural log means base is e raised to power 4. What should e be raised to get e raised to power 4? That is obvious, it is just 4. Natural log of 1 by e. That looks like this. What should e be raised to get e raised to power negative 1? That should be just negative 1. Next, we have some basic properties of log. We know always that b raised to power 0 is always equal to 1. Using that, we have the property that log of 1 is always 0, does not matter what the base is. It's a very important basic property of logs. Log of 1 is always 0. So using this property, let's look at example number 5. Here, question number 6, natural log of 1 would be 0 because log of 1 is always 0, doesn't matter what the base is. Question number 10, answer would be 0. Why? Log of 1 is always 0, does not matter what the base is. Question number 4, log of 1 with base square root of 7 will also be 0. Log of 1 is always 0, no matter what the base is. Next property is log of a number with the same base b. If the base is b and you're finding log of that number, that is 1. Why? Because b raised to power 1 is what? B, right? B raised to power 1 is itself. So log of a number with the same base is 1. So that means if this take example number 2, answer should be 1 because the base is 11 and the number itself is 11. Question number 3 here, log of 10. Common log, base is 10, that means the answer would be 1. Natural log of e, that means the base is e. So this is log of e with base e, that should be 1. Then we have log of b raised to power x where the base is b is equal to x. So this is exponential and log. They cancel each other because they are inverse function of each other. That would be just x. So log of 3 raised to power 10 with the base 3 would be just 10 because log base 3 and exponential function cancel each other. Natural log of e square. Again, log base e and e exponent cancel each other. The answer would be 2. Also, b raised to power log bx. B raised to power log of x with base b to be x because exponential and logarithmic cancel each other. So that means 5 raised to power log of c square plus 4 with base 5. If the base is same as the exponential, they cancel each other. The answer would be just this. Number 10, 10 raised to power log, common log, the base is 10, so they cancel each other. Answer would be just a square plus b square. 11th, natural log of e raised to power negative 12. Natural log is log with base e raised of e raised to power negative 12. Natural log and exponential cancel each other. The answer is 12.